Hello everyone. So we'll present you a solution proposal called MBSE Vision 360, which is a tool to facilitate the understanding of complex models, MBSE models, for non-experts, let's say. Okay, so we identified different challenges during the systems engineering today. The first challenge that we want to address is related to the complexity of the systems. So today's systems complexity grows, and a lot of dependencies between systems are exhibited, and it's sometimes quite difficult to understand this complexity. The second challenge that we identify is related to silos and business silos, where a lot of systems are multidisciplinary systems and requires many expertise, like safety or different physics. And in many organizations, the different disciplines are driven by different specialists and do not necessarily communicate with the same page. And the last challenge that we intend to address is how to detect issues as early as possible to minimize the cost of late detection. Yeah, so in this context, we highlight here, so because we are an MBSE, so we highlight on the left the MBSE domain, where you have a lot of models defined with different modeling capabilities. So defined by system modelers, where they define the needs and the different solutions and architecture elements into the MBSE domain. But they do not realize these MBSE models only for them. So they have to share this information with many stakeholders. So in particular, with different system specialists and disciplines, and to ensure that the understanding is correct and the same with these different specialists. They have also to communicate and the progress of this MBSE and architecture, and provide some different KPIs or different status related to the progress of this activity. And finally, we have to connect also with different disciplines like requirements and integration, verification, validation disciplines with these engineers, and we have to connect these requirements directly to the models elements. So why using model-based systems engineering approach? So you have some pros on the left. So it supports the formalization of complex architecture and facilitates different step-by-step approach to decompose the needs from the needs to a detailed solution. It also facilitates the consistency checks and the verification and validation of different properties that are formalized in different specific elements. It's a support to enhance the quality of requirements definition and provides formalized syntax and semantics. But we discover or detect in many organizations that we have different difficulties. It may require important learning curves for non-experts. And in several organizations we face, we have identified that we generally have three different roles. The systems architect, who are really specialists of the architecture of the system, the requirements engineers that define the requirements and detailed requirements in generally specific tools for that, such as ALM, application lifecycle management, and finally, MBSE specialists who formalize the system architect decision into a MBSE model. These models and requirements need to be shared with different stakeholders in the organization, where these stakeholders are not really always familiar with this syntax and semantics. The project management office needs regular information about the progress to monitor the quality and the progress of the architecture. So here we focused on the Arcadia method and the Capella tool, where we have already, I think, detailed this zigzag between requirements and models elements in a previous webinar. But in the left, you find the ISO, standardized ISO 15288 activities. And on the right, you find the different Capella Arcadia layers. The middle column refers to an example of specific requirement documents that are defined by requirement engineers. And there is a zigzag between the requirements and the model. So you come from the, for example, business requirement document at the concept of operations levels, define some model elements in the operational architecture of the Arcadia method, and then flow down to the subsystem requirements definition. So you find stakeholder requirements specification, system requirements specification, and the software system architecture document in the flow. So why we have proposed MBSE Vision 360 is to first get an overview of the data model and the relations without a required MBSE expertise. So we will demonstrate it, but we display the data graph and dependencies to explore the topology and dynamically educate users and also have a way to access directly native diagrams. And you have some different search engine to research specific elements into the model. We also provided to assess design and architecture decision for non-specialists to easily view and understand how we structure the model, how to access some elements, and to navigate easily in this. We also propose to assess the architecture progress, traceability, and consistency by providing some requests and semantic checks that is embedded into the tool. We also propose how to detect allocation inconsistencies or optimization opportunities. We will demonstrate that we have also implemented a mechanism to view a kind of complexity of interfaces into the tool. And finally, we enabled the review of functional allocations and distribution over space of the functions into the systems and to specific physical components. So this is really a navigation tool which proposes some specific KPIs and offers some review facility for non-experts. To illustrate that, we will focus on a dedicated use case. The use case is extracted from the well-known use case from IRT Saint-Exupéry. It's called the AIDA use case, so for aircraft inspection by drone assistant mission. It's an open source case study on the Creative Commons license. And this system is in charge to perform, to assist human to perform the pre-flight checks of the aircraft before flight using a drone UAV to perform this operation. So by going step by step to different points of interest and capture some pictures and compare to a specific database, and this offers a kind of service for the line maintenance operator. This model is provided also as open source in Capella, as a Capella model. and it offers large views from operational analysis to physical architecture, and contains many views and systems that brings a large complexity into the model. So we used it as a proof of concept for the MBSE Vision 360. And now I will give the hand to Ulysse, who will present you the tool.
Hello. Yes, for the second part of this webinar, we will discover MBSE Vision 360 in detail. How concretely all of this is concretized into the tool. But first, I will give you some technical information, because you have to know that this tool is a standalone proof of concept Capella model viewer. We are not modifying models, the Capella model. We are not linked to a specific Capella version, and to run this tool, you don't need to have an installation of Capella on your laptop. It's very standalone. The backend, the data processing and data extractions are performed by the Capella MBSE library. And for the user interface, we have some scripts in JavaScript and HTML. To continue the presentation, we organized this tool in 2 missions, split in 2 use cases for each. The first one is to democratize the MVSE, to let every project stakeholders to explore the system easily and in a very intuitive way, and break silos, break team silos, so everyone can discuss and focus efforts on the same model and understand the model. The 2 use cases of this mission, the first one is to accelerating project onboarding and system discovery, and the third one, visualizing connections and traceability. The second mission is for system experts to review the model and make the system stronger, more robust for project milestones, with the first use case to review the model quality, to perform queries, specific queries, to match the organization needs, organization process, and to check some attention points of the model. And the last one, the use case 4, is to evaluate interface design and architecture complexity by visualizing end-to-end traceability and using in experimental way the n-square matrices. So let's switch to the first use case, accelerating project onboarding and system discovery. It's for people who need to understand the system, to trace the system, but don't need to model it, don't really need to model it. It's just for MBSE newcomers or people who don't know the Arcadia methods. We offer 3 functionalities for this use case. The first one is an intuitive 3D exploration. The second one, breakdown structure visualization. And the last one, a dashboard to get some information, to get some KPIs, some indicators on the model, to have an overview for a project manager, for example. For the first one, 3D exploration, we represented the model in 3D from the operational analysis layer to the physical architecture layer. Each model element is represented by a bubble, and each color it's specific to an element type. For example, we will have in green the model functions. In blue, every actors of the model. So the purpose of this view is for a quick exploration, high-level quick exploration, to get an overview, but not to go into the detail. To go to the detail, we will have at the top a kind of spotlight. So specific elements, for example, you can search for flight or motor or drone to access some terms related to your search. And when you click on an element in the spotlight, it will be automatically highlighted, selected in the 3D model. So it's easier to locate what you want to check. And at the right, you have a side panel with 3 tabs. The first one is the property tab to get some information of the selected node. For example, its name, its layer, its type, its description, review status if it's filled in. And as the use case 1 and globally the first mission are dedicating to people who don't really know the MBSE, how newcomers on the project, we also implemented a pedagogy frame to give some Arcadia concept explanation and to more precisely let the people learn the role of the selected element within that specific layer. So it's a kind of contextual guided tour of the Arcadia method and the model. The next one is the breakdown structure visualization. So it's an automated hierarchical breakdown view where the users are invited to select first an element type and then a scope. A scope is basically a model layer, operational, system, logical, or physical layer. And automatically we will have the breakdown displayed. So it's pretty clean. The user don't really have to interact with the graph, but he can expand or collapse some nodes. At the top, you have some metrics like the tree depths, the number of leaves, the number of elements, and the possibility to export the model, to export the view, sorry, to have a snapshot to download it as a picture. In the scope dropdown, we not just have the layer, we also have a cross-layer traceability. It means that we will combine every layers into one single view. And for example, in the example shown currently, it's about components, but for example, for the functions, you will have in the same view the breakdown structure of system functions, logical functions, and physical functions, with the links, the traceability links, layer by layer. So you will be able to see the structure refinement layer by layer become bigger, and you can control how you are declining your architecture across the model. And the last functionality for this use case is the monitoring dashboard. First, we just put some basic indicators, but we would like to implement complexity and objective quality metrics with customers that are interested with this functionality. But we start to have some tabs for a demo purpose. So I will not go into the detail because it's not the indicators are not really relevant. It's just to show you that it's possible and we are working on it. Every tab data are coming directly from the model, except the last one, the model review, that is a kind of summary of rule checking, but we will see that in the third use case 3, and the review model quality. And it's not working now, but we would like to extract some temporal data, so to save a snapshot, to capture the state of the modelization at this time, to reload it later and compare with an evolution, for example. For the second use case of this mission, visualizing connection and traceability, it's for safety system and VNV engineers who need to trace the need to from the top layer the organization operational analysis to the physical architecture. We also offer functionality to visualize allocations and potentially missing allocations. And the last one, the run trip between the requirements levels and the model. So the first one about the relations, the connections, we will focus on the two last tabs of the side panel. They are almost the same, but they are not addressing the same purpose. For relations, we will first select a node in the 3D graph, and we will. The question is, what can be affected if I change or remove this element? So it's a kind of impact analysis. If I select a node in the 3D graph, I will have its direct linked element, and I have a slider on the panel to increase the exploration depth. But I recommend to not go over 2 or 3 because we will have the whole model highlighted and it will not be very interesting. You also have the possibility to display a contextual graph, to switch from the 3D model to a 2D view. You can move boxes, you can rearrange the view. You have a legend, and you can export everything as a snapshot to, for example, for a meeting to discuss a specific part of the model with your team. And the traceability tab is a bit similar, but we will use it to justify the solution against the need and to demonstrate that every need reach the final design, because we only focus on the layer-to-layer links, not the links inside the same layer. Just the traceability recursively from the top layer into the last one. And also with a contextual graph to focus on the selected elements. The second one is to visualize allocation, model allocations. This time we switch the view. We are not in the global layer view. We are in the layer by layer view, pretty similar to the architecture blank diagram in Capella, if you know. And we have with this view two information. The first one is structural. So we have structural elements like actors and components directly placed on their parents. And the second information is the allocation for missions, needs, functions that will be placed on their allocating components, equipment, or actor. So very similar than the architecture blank diagrams. And we also introduce white boxes to materialize, to visualize quickly unallocated functions. And for the physical layer, the physical behavior that have not been deployed on the physical hardware. So it's another representation to focus really on the allocation and control that we don't forget something. And the last one is the round trip between the specification. We are back in the 3D global view. You have 2D icons representing the specification, and when you double click on it, you will be able to browse into the specification and select some requirements, access their information, and directly see in the 3D view what is linked to this requirement. We also have a dedicated window to materialize the round trip. It's pretty similar but the panel of the specification, but here we will trace the link. We will follow the flow from the top to the bottom, very similar than the traceability tab, but with the requirement this time. So, for example, in this dedicated view, I can select the top business requirements and see how it's implementing through the model. For example, the business requirement, its impact in the operational layer, then linked system architecture elements, the system architecture requirements, etc. You can do the zigzag. Sébastien explained you later before directly in this contextual diagram. So we will be able to see how requirements constrain the model elements, and at the opposite, how the model elements like scenario, functional chains, functions initiate requirements at a lower level. So really the zigzag. But this part is a bit experimental for the moment. We need to go further with some metrics, some coverage rate, etc. And that's it for the second use case of the first mission, to democratize the MBSE and make it more affordable, to ease the onboarding on the system model visualization. The second mission is to support the expert in the model review to make the system stronger. With the first use case, that is review the model quality, we're offering to the conceptors and system architects the possibility to create queries for attention points, for the gap identification, and, for example, to create a specific scope for a domain like safety, for example, some set of rules to check the safety of the system. So let's see how it looks inside the tool. It's a user-friendly query building tool, query builder. First, you can select predefined rules. For the moment, we implemented some rules like to identify isolated elements and allocated functions, etc. But you can define your own set of rules based on your processes, based on your toolchain, etc. So we propose something very generic, but you can import your own rules because it's the rules are saved in the JSON format, so it's very common, and you can edit it, share it, etc. You can also customize your query. You can, based on an existing query, and modify it, but also start from scratch by defining a scope. It's the layers you want to focus on. An element type. For the moment, we just have one element type per query, but later we can have, for example, several element types. You can filter on properties, for example, to filter on elements containing a specific text, elements with missing descriptions, or elements with a specific review status. And then to filter on the links, to filter a specific link type, for example, to check unallocated elements with no parents, with no children, with no propagation to the next layer. So you are very free to do everything you want with this type of query builder. And then when you apply your query, you will have three ways to view the results. The first one is the list view. It's a table showing the properties of the matching elements, and you can export it in CSV format. The next one is a card view. It's a grid view to have a quick scan of every matching elements. And if you close the window, you will have you can go back to the 3D model and just have the matching elements. So yeah, the purpose of this use case is really to offer some tools to the conceptor, to the system architects, to review deeply their model. And the last use case of the second mission is evaluate interfaces design and architecture complexity, also for system architects, and this time for interface managers, with two functionality: to visualize the end-to-end traceability of functions, scenarios, exchanges, and to identify coupling elements, making the architecture a bit complex. So for the first one, for the end-to-end traceability, we are back to the layer by layer view, but this time we give more space to the elements. We are in a kind of exploded view. And in the side panel, you will be able to filter on a specific chain or interface, select a matching element, and directly visualize it into the 3D model. So in red, you see the altitude control loop functional chain I selected, but not only the functional chain, you will be able also to see the involved structural elements supporting this functional chain, and also the trace in the other layer of this chain to see how it's refined layer by layer. For example, I selected system at the system level, a functional chain. I can see directly in the 3D graph how this chain is implemented at the logical architecture layer, and everything in the one single view. You also have a contextual graph to have the two-dimension visualization. You can move box, export the ledger, as we saw previously. And also, we started to have some interface sheets information for the interface, like the interface name, source and element information, traceability and model coherence across the whole model, across the layers. And for the last functionalities of the last mission, we are focusing on n-square matrices. The purpose of this window is to focus on data flows and architecture complexity. So we will have in the diagonal the functions of the components, and the wires are representing the oriented interaction between two elements of the diagonal. And we will have at the top the possibility to activate an algorithm to rearrange the diagonal, to make another order of the element on the diagonal, to make a cleaner data flow view, and it will enable to identify quickly the coupling elements, because coupling elements are elements that have a kind of looped data flow. They are working together, and it's very interesting to identify them because they are making the architecture more complex. And for example, for the IVV activities later, it will be a subject. You need to identify them because you have a dependency inside this kind of elements. So it's for example, it's for the moment it's just an experimental view, but we would like to produce some metrics and some architecture optimization on it. But it's just a first view of what we can do with this kind of data retrieved from the model. And this concludes with the model presentation. So what you have to keep in mind is we have one tool for two missions: democratize MBSE for everyone, to make involve every stakeholders of the project on the same model understandable. And the second one is to make system more stronger with proposing some review tools, and all of this without modifying the Capella model and without replacing Capella. So thank you, and I will let Sébastien to do the overall conclusion.
So thank you, Ulysse. As a conclusion, so as you have seen, it's we developed it as a proof of concept with some preliminary customer where we have identified this kind of needs. And we already have performed a run during this first part of the year with some customers which provide us some first feedback. So we see that there is a specific interest to get a user-friendly interface to explore, analyze models, and analyze the traceability for non-MBSE experts. We see a place for that need. We see also that we discussed also that it seems that it could be difficult today to visualize, in particular, the functional chains distribution over the space, how they are distributed over space. And we think that the 3D view that we propose may address this challenge. And they have interest to perform some reviews, guided reviews. As we present you the tool, this tool is not finished yet. It's a proof of concept. So we have identified today future steps and future potential functionality to explore with specific interested customers, like the monitoring model progress, in particular, as mentioned Ulysse, to perform a snapshot over time and to see monitoring KPIs of the progress and the complexity of the model. We have presented briefly a kind of request to perform reviews, but we would like to enhance it and provide a full review process that is guided with checklists, get the review comments and results, and the consolidation of the review, including the review process. We envision also to extract some kind of interface control documents and to get kind of interface lists to analyze and discuss about the interfaces. And we also envision to extend, because today it's Capella developed based on Capella, and if we see that it could be quite easy, or the principle can be extended to SysML or SysML v2 models in the future. And probably we would like also to address the trade-offs analysis and comparison between solutions. That's also something that could be enhanced. So thank you very much. And if you have, feel free if you have any question to. So in addition to complex models visualization, do you propose add-ons for Capella that support model simulation and code generation? I would like to maybe to answer in two parts. The first is that what we presented, maybe Ulysse can confirm, but it's not really an add-on of Capella because it's a standalone application. So it's really independent from Capella, and we do not intend with this add-on to perform some specific actions on the model. It's really a kind of passive action. So let's say, briefly, that it was not the initial intention of the tool to address this kind of features.
Okay, thank you for the answer, which is for MBSE approach shared between several companies. Is it possible to display the transition between several MBSE models, like system
it's a really excellent.
It's in our roadmap.
Subsystem ones.
Yes, Sébastien can reply.
Oh, you can. Yeah, it's on our roadmap. It's really an excellent question, but for the moment we addressed only monolithic models. But we, for sure, it could be a need, so to scale and go into these different related models, in particular in the extended enterprise context. Product line engineering point of view, is it possible to display? So possibility, yes, could be really interesting.
Can you see the question well?
Yeah.
Okay, yeah. So yeah.
I can read the questions if you have a bad
maybe
connection.
it's safer to do like that. Yeah,
I think so. So for product line engineering, is it possible to display variance with a 3D graph done with pure variance, for example? It's also an excellent question. Today we did not perform this operation yet, but as we use really often product line engineering, it could be a very interesting things to do, but not addressed for the moment.
Okay, thank you. Next question.
Is the add-on free and open source, and how we can try it out? So as I mentioned, it's not really an add-on, so it's a standalone application, and we think that it's a POC that should be customized for any customer. So today, maybe it will change in the future, but we don't expect to make it open source. But we use it as a specific internal asset that we will be pleased to discuss specifically with interested customers. So if you are interested in, we suggest to contact us. We have the contact in the end of the presentation.
Okay, great. Thank you, Sébastien. So next question.
How dynamic is the requirements can be handled? For instance, if there is a change in one of the requirements, would it be possible to visualize the impacted items and notify the relevant systems, accordingly followed by feedback on change approval accommodation? I would say that everything is possible. It's really interesting feature, but it's, I think, related to the process of company and change management process, which is not yet integrated in our tool for the moment. But it's really interesting topic also.
Sounds good. Then next question by Arona. Can this be integrated to Capella in order to be able to see in real time if the model is modified or changed and see the chain of modification?
Ulysse, do you want to answer?
Yes, so for the moment it's a very passive tool. Just reading as input the Capella model files. You just upload them one time. So we didn't plan for the moment to make them to make a dynamic integration with Capella. We need to maybe integrate it in the roadmap, but for the moment it's not planned.
It's also, I think, interesting one. Would it be possible to link the requirements to test cases using this plugin, a view in graphical representation, please? As far as I can understand, the requirements and test cases may have somehow similar representation, so I don't see any showstopper to do it, but it was not yet implemented. So maybe I can just tease that we will also present this in a next event for AALM event and connection with Polarian tool that will be presented in a few days. But we focused yet on the requirements topic and not on the IVV for the moment.
Okay, thank you. So, new question again.
Is it possible to edit elements in the graphical view?
Not really, but it can be part of the review, maybe. The review we mentioned in the future steps to make comments, but for the moment, we don't have the possibility to edit anything. It's just a viewer.
Yeah, so it was, we can complete maybe to say that it was not an initial intention to make a double edition of the Capella model with external tool and Capella tool. Capella stay in our vision, stayed the editing tool and the Vision, MBSE Vision 360 more a review tool, so can add requirement review comments, and that's all.
Okay, great. How can this modeling favor modularization?
I'm not sure to understand exactly the questions, but maybe I can answer as I understand. We propose a really preliminary draft of n-square graph that has been presented by Ulysse, and we may also propose in the future kind of optimization algorithm to support optimization of allocation of the functions to the components using these famous n-square matrices and DSM algorithms. I think this facility can help the modularization to minimize the complexity of the interfaces. But there is also other aspects to consider that are not supported by the tool itself. Yeah, does MBSE Vision 360 also display links traces when using system to subsystem transition? I think it's quite not duplicate, but related to one or the two second one, related to the extended enterprise and different systems. So as I mentioned, it's not yet done, but it's on our roadmap. So how are review comments and their follow-up handled? Can the differences before and after the change will be visualized? More generally, could the tool be used to show the difference between two versions of the model? So as I mentioned during the conclusion slide, it's also on our roadmap. Today, we have performed only simple queries to review and support the visualization. But it's clearly a process that we would like to introduce in the tool, but it's not yet introduced for the moment. I think we have in mind to introduce review comments and the decision to say at the review if it's critical, not critical, each comments, and to associate them to the model and to see a review final decision into the tool, but it's really not yet done.
Thanks again, and bye to everyone.
Thank you. Goodbye.